The cow's been milked here this morning. These are highly productive animals producing high quality milk, and what my job is about is trying to figure out which of these animals are producing less methane without any compromise in productivity. I'm a geneticist, so I look at the individual genes, and we know where all these genes are for milk production, fertility and health. And the question that we're posing now is, can we actually find the genes associated with methane production in these animals? Calves are the most important resource on a farm because they're your next generation. And traditionally, these calves would have been bred for economically important traits like milk yield or meat quality and yield. What we want to know now, of course, is genetically how much methane are they going to produce. We can take a sample of the animal's ear, and the genetic code is within that will tell us not just how productive they're likely to be, but also how much methane they're likely to produce.
So this is a green feed unit. It is used to measure gas emissions from cows, predominantly methane emissions. So what happens is the cow puts her head into this unit. It's got an RFID reader on the inside to read her tag, and it drops some concentrate pellets from a bunker up in here. And then as she's eating, she's huffing and puffing away, expelling the methane from her breath. The air is being drawn past here and it's being captured by the machine, and the methane's getting subsampled and compared against the background concentrations of methane in the atmosphere. So these machines are only snapshots of what the cow's producing. It is only 2 minutes out of that full 24 hours. So as we can get multiple snapshots at different times of the day, we can start building a bit of a profile of what she's producing.
The Roadmap project has been going for just over a year now. We've one of the largest databases in the world in dairy, in beef and in sheep on individual animals, how much methane they are producing. So the question that we had was, how much of that variability is actually due to genetic differences? And in fact, around 20 to 30% of the variability in methane we see amongst animals is due to genetic variability that we can exploit within our national breeding programs. So this is the outcome from all of our research, where farmers can go online, they can search individual bulls and how much methane they are likely to produce and their progeny are likely to produce, in combination of course with all the other economically important traits. So we can see here, this top bull here, he has methane information on 325 of his progeny, and he is favourable for methane, so he will produce less methane than the average. Him or his progeny are expected to produce around 5 grams less methane per day, which sounds a small amount, but then when you push that across 6.5 million cattle in the country, that can be quite substantial. We see around a 10 to 20% difference in the methane output of individual animals holding their production the same. And from that, we can see that around 20 to 30% is actually due to genetics. That's crucially important for us as animal breeders, because we're all about finding the animals that are genetically the best or genetically the worst. So just looking at those animals, you don't know which of those are genetically the best. We need to look into that individual capsule of DNA and see, yes, they have the good milk genes, the good fertility genes, the good growth genes, but they also have the bad methane genes. And they're the animals then that you want to select within this breeding program, where we rank the animals not just on their environmental credentials, but really importantly on their economic sustainability.